In topic 2, we're going to simplify exponential expressions, but now they're going to contain the potential for negative exponents since we've learned that new feature. So for any exponential expression, you know it's fully simplified when each base only occurs once. So typically that means you're going to have one coefficient, you're going to have one factor of each type of variable. Okay, no parentheses appear, no powers are raised to power, so you can't have like a power rule that needs to be addressed, and you're going to have no negative or zero exponents. Okay, so let's look at these. So first of all, example 2 just says simplify each exponential expression. So starting out with part A, we have z to the negative 15th times z to the 9th. You can do this two ways. You can write this as a quotient where you go ahead and deal with your negative exponent, or you can apply the product rule and then deal with your negative exponent. Doesn't really matter. It's the same amount of work either way. I see a product rule first. Remember, the product rule says if you're multiplying two expressions with the same base, you keep the base and you add the exponents. Well, that's going to give me z to the negative 6th power. Well, remember, when you have a negative exponent, you have to move that piece. So I like to think of this as 1 over z to the 6th power. And that just goes back to that definition of negative exponents. Now, you could think of this as z to the negative 6 over 1, or 1 times z to the negative 6 over 1. This moves, which leaves behind a 1, and then 1 times z to the 6 is z to the 6. You're going to get the same answer either way. Just know that that ends up with a negative exponent that you need to simplify. For part B, we have negative 15x to the negative 3rd divided by 9x to the 6th. So of these four distinct factors, there's two factors in the numerator, 15 and negative x to the negative 3rd. There are two factors in the denominator, 9 and x to the 6th. The only one that needs to move is x to the negative 3rd power. So we are going to start by moving this. So let's see what that leaves behind. That's going to leave behind negative 15 in the numerator. The denominator is going to be 9 times x to the 6th times x to the 3rd, which is negative 15 over 9 x to the 9th. Now, this is a product rule. We're multiplying two things that have the same base. We keep the base, we add the exponent. So 6 plus 3 is 9. Now, we also have to address the 15 and the 9. You always want to see if there's common factors that could be divided out. And in this case, there are. There's a negative, well, there's a 3, we'll say, that could be divided out. So when we're dealing with a negative divided by a positive, the whole end result is going to be negative. Now, as far as 15 and 9 are concerned, they're divisible by 3. So when I take 15 and divide it by 3, I get a 5. When I take 9 and divide it by 3, I get a 3. So our final answer is going to be negative 5 over 3 x to the 9th. And that's it. Okay. Now for part C, we do have a product to a power rule that we need to deal with. So this exponent of 2 here, because this is a product, I'm allowed to bring that exponent in to each factor of the product. So this is going to become 4 squared times x to the 3rd squared. And then the denominator just remains x to the 11th. Okay. Well, 4 squared is 16. And then this right here, x to the 3rd squared, that's a power rule. That tells me if I have an exponential expression raised to an additional power, I keep the base and I multiply the exponents. So this is going to become x to the 3 times 2, which is x to the 6th, over x to 11, or x to the 11th. Now, how you deal with this is up to you. You could go ahead and you could move. Is it negative? No, it's positive. You could try to do the quotient rule, which would give you a negative exponent, and then move that negative exponent. That's one way to do it. I like to think of this a little bit more logically. I ask myself, am I top heavy or am I bottom heavy? I'm bottom heavy here. I have more x's in the denominator than I do the numerator. So that tells me those 6 x's in the numerator are going to cancel 6 of the 11 x's in the denominator. So 11 minus 6 is 5. That means there's going to be 5 x's left. But where are they going to live? Because I'm bottom heavy, they're going to stay in the denominator. So this is going to become 16 over x to the 5th. Now, if you don't like thinking about that kind of logically, you could certainly do the quotient rule, which would give you 16x to the 6 minus 11, which is 16x to the negative 5, but this has to move, which gives you 16 over x to the 5th. You could certainly do it that way if that makes more sense to you, but I like to kind of think of them logically. So I typically just think, where am I top heavy or bottom heavy? And then that's where the leftovers are going to live. Okay. Now, finally, part D is a little tricky. Some books do teach you a quotient to a negative power rule. We don't have that rule in this book, so we just have to kind of go about this the way we know how to go about this. So this exponent on the outside is going to come into each part of this quotient. Okay. So I'm going to get x to the 8th to the negative third divided by x to the 4th to the negative third. This is one way to do it. I'll show you another way in a minute. So this is a power rule situation. So for the numerator, I get x to the negative 24th divided by x to the negative 12th. Well, we can flip-flop these because this needs to go down here. This needs to go up here. That's one way you could think of it. Or you could do the quotient rule. So let's say we do the quotient rule. So that's going to be negative 24 minus negative 12. Well, that's going to give me x to the negative 12 power because negative 24 minus negative 12 becomes negative 24 plus 12, which is negative 12. And then this just becomes 1 over x to the 12th power. That's one way you could approach this problem. Okay, so kind of write this down if you like this, if this makes sense, that's great. There's another way that's a little bit easier, and this is how I would generally do it myself. So let me erase all of this, and then let's look at it again. When you have a set of parentheses like this, it's nice if you can simplify what's in parentheses first, okay? So I notice inside parentheses, I have x to the 8th divided by x to the 4th, so I'm dividing two expressions with the same base, so I can keep the base and subtract the exponents. So the inside just becomes x to the 4th, and then I can apply the negative 3 power. So this is a power rule. So this gives me, let's see, x to the 4 times negative 3, so x to the negative 12th power. But I can go ahead and think of that as 1 over x to the 12th. So either way you approach this or think about this, you're still going to get 1 over x to the 12th power. It just kind of depends on what your preference is. I think this is a little smoother. So for me personally, if I have stuff inside parentheses, I like to simplify it as much as I can and then bring in those negative exponents or those positive exponents, whatever the exponents are on the outside. It's up to you. That's the thing about these problems. There's lots of ways to approach them. It just kind of got to start somewhere and simplify it fully.